Okay, welcome back. So the first thing that I want to do is talk about this idea in a little bit more of a rigorous way. So, this was all here, this was just to sort of give you an idea of, yeah, okay, I guess this person would prefer smoothness. And so let's see this in a little bit more of a serious way. So here's what we're going to do. We're going to say, so suppose someone could choose C1 and C2, but they were limited, and this is going to look really familiar, hopefully. So they are limited to C1 plus C2 is equal to 200. And so, of course, what I meant by this should look familiar, this statement right here, this is a budget constraint. It's a little bit of a different budget constraint because it represents consumption in different time periods, but it's really kind of the same thing, right? As if we're talking about apples and bananas. And so, by the way, we'll keep assuming that the utility of C1, C2 is equal to exactly what it was before. Okay, so this is just a maximization problem, but it's good to see it in kind of a different context. So I'll use the substitution method for this problem, although of course you could use the Lagrange method if you preferred. So here's what we would do. We would say that so we want to maximize root C1 plus root C2. So what we want to do here is to substitute for one of them, right? So we'll use the substitution right here. So we'll say C2 is equal to 200 minus C1. So that means that we're now trying to maximize root C1 plus root 200 minus C1. And then we're just choosing a value of C1. Okay, so we just need to take our first order condition with respect to C1. So we would get 1/2 C1 to the negative 1/2. We would get minus 200 minus C1 to the negative 1/2. And so remember, by the way, that the negative here comes from the chain rule, right? Because we have a minus C1 inside, so that's why we need to make sure we have a minus here. So all of that is equal to 0. So we have 1/2 C1 to the negative 1/2 is equal to 200 minus C1 all to the negative 1/2. Oops. Okay, so now what we need to do is we can just raise, let's take both sides to the, to the negative first power. So this will be, so this will become 2c to the 1/2 is equal to 200 minus C1 to the 1/2 power. So basically what I did here is just to raise this side of the equation to the 1/2 power and raise this side, to the negative 1 power. And then on this side, raise it also to the negative 1 power. So the raising 1/2 to the negative 1 power, that's just the same as 2. Negative 1 power just means flip. And so then we have C1 to the 1/2 and all of this to the 1/2 as well. Okay, so let's square everything. So squaring will get rid of the 1/2, but we also need to square this 2. So 2 squared is 4. So 4c1 is equal to 200 minus C1. So 5C1 is equal to 200. That's not what I was expecting at all. Okay, so clearly I have made a mistake somewhere. Let's go back and look for it. Aha, okay, so we'll backtrack a little bit. So remember, so when I did this derivative, I correctly brought along the negative for the chain rule. I forgot to actually take the 1/2. So right, because when you take the exponent, you need to bring the exponent down. So that means that we have an exponent 1/2 minus 1/2. So so that means we should have a 1/2 here. And then these two 1/2s just cancel, right? Which means that there's no 1/2 here. So this 4 should not be here. So this is just 2C1 is equal to 200. And C1 is equal to 100. Okay, so that's what we should have. And then, of course, C2 is equal to 200 minus C1 is also equal to 100. So the one thing that we should double check is, hey, did we find a minimum or a maximum? Because it's not all that clear, right? Maybe having your consumption split is like the worst of all worlds. So let's just double check. And so there's a lot of different ways to double check. One thing you could do is look at the second derivative. I'm going to use a slightly mathematically easier way to do that. And I'm just going to check the utility of 100. We know that's equal to root 100 plus root 100, which is 20. The utility of 0, 200 is equal to the square root of 200. And that's not something I know off the top of my head, but that is much less than 20. And so we can be sure that 100 is a max, not a min. Okay, so all of this was to say that if you wanted to find how this person would choose to split up their consumption of $200, they would choose 100, 100. So that's just indicating that, yes, indeed, this person does prefer smoothness. Okay, so I'll take another quick break, and then when we come back, we'll talk about an example that is that we can use to shed some light about persistent inequality.